Hello all and welcome to an exciting video lecture in engineering mathematics brought to you by your instructor Srinidhi from the Bharadwaj Academy. The subject engineering mathematics only forms a small part of your engineering curriculum, but in reality it has to offer for more than 90% of your core engineering concepts. Hence, it becomes very necessary to understand the higher level engineering mathematics in a simple and elusive way. So, we are in the first module, which is the differential calculus, in my 4-part series of lectures on engineering mathematics. This is the first video lecture on successive differentiation, where we'll be talking about its introduction with the standard forms. So we have a function y is equal to f of x here. Now dy is equal to dy by dx is the first differential which tells us the rate of change of variable y with incremental change in x. But that's just the basics. However, dy by dx is also another function which can be differentiated many times. So let me demonstrate with the help of an example. If we have y is equal to x power 5 plus x cube, let's say. So dy by dx is 5x power 4 plus 3x square. Now, as you can see here, there exists a second differential which can be stated as d square y is equal to, yes, 20x cube. Of course, the formula which I'm using is nx power n minus 1 for polynomials plus 3 2s are 6, 6x. Now, I can continue this for d3 and d4. And finally, we can generalize this for nth case, where we get what we call as the concept of nth derivative. Yes. So we will look at nth derivatives of some of the most common functions. Firstly, a polynomial. Here is the formula for nth derivative of a polynomial. So this is a basic straightforward formula. We will see with an example. What is the fifth derivative of this function? Y is equal to 2x plus 9 to the power 6. Yes. What is the value of m? First things first. Let's take the value of m. M is equal to 6. N is equal to 5 because it's the fifth derivative. And what is a? This a is equal to 2. The most important thing here to understand is this particular variable, right? This particular variable term. So 6 minus 5 plus 1 gives me 2. What is the importance or significance of this 2 is, you know up to where you need to stop going from 6 to this number. Like you need to proceed from 6 to 5 to 4. Why? Because it's given m into m minus 1 into m minus 2. But up to where? Right? So into 3 into 2. Yes, we have to stop here because we have reached this term. And of course, you have a power n, which is 2 power 5. And multiply this with a given expression 2x plus 9 power m minus n, 6 minus 5 is 1. We will get the answer as this. So the next case is function in the form of 1 by ax plus b, basically the inverse x function. Here is the formula for the nth derivative, right? We will of course see an example of the previous case, but before that, Let's see another important function with a similar result. Yes, logarithms. Y is equal to log ax plus b to the base e. So here is the formula for the nth derivative of this function. Now let's see an example. What is the fifth derivative of log 2x plus 9 to the base e? So direct application of the formula. Minus 1 power 5 into n minus 1. Yeah, since it is log, we need to do n minus 1. N is 5, 4. 4 factorial into 2 power 5. 2 power 5. Yes. So a power n, which is 2 power 5, divided by 2x plus 9 into n plus 1. N is 5, so 6. On solving this, we get an answer similar to this. Observe the minus sign here. We get the minus sign because minus 1 is raised to an odd number. If it was raised to an even number, we would have got plus in the answer. So this is kind of a check to see whether you are right or you are wrong. Now we will see another standard function which is very easy to remember. You just have to multiply m power n, n. But yeah, we'll see more of our buddy e power mx when we talk about Leibniz theorem. But it is time we call our most important buddies. Yes, I know what you're thinking. Sine and cos, right? Yeah, the formula for the nth derivative is plain straightforward, except the presence of this terms. Yes, this might lead us to some, a thinking. But we'll see how to understand this. But before that, we need to give you, but of course we'll understand that with an example. What do we have here? Fourth derivative of y is equal to sine 6x. Fourth derivative. What is 4? Whether it's an odd or even number? Of course it's an even number. But why are we doing this odd and even thing right now? Let us see. So direct application of the formula will give us n fourth derivative as 6 power 4 a power n into sine 6x plus n pi by 2. What is n here? 4 pi by 2. Now observe this term 4 pi by 2. 4 pi by 2 is nothing but 2 pi because 2 cancels 4 to give 2. 2 pi is, this is pi, 2 pi. So 360. Once you complete a circle, you get back into the first quadrant. You get into the first quadrant, which is the starting point. So here is your answer. Sine 6x. It remains as it is. But how do we generalize this? This is the answer. Let us draw the coordinate axis, which is basically your xy plane. I am writing these letters A, S, T, C in anti-clockwise direction. The significance of writing ASTC is that in the first quadrant here, all the trigonometric ratios, sine, cos, tan, cosec, secant, cot, all their signs remain positive. Yes, in the second quadrant, only sine remains positive. In the third quadrant, tan remains positive. In the fourth quadrant, only cos values remain positive. But what's that got to do with our concept of nth derivative here? Let us see. But before that, there is a small mnemonic to understand this sequence. All students take coffee. This is a general mnemonic which has been taught to help you understand whether the trigonometric ratios. Okay, that's fine. Not a big deal, but what's that got to do with our nth derivative here? Let's see. Remember when I said whether n is odd or even? N is an even number. But why did we take this? If we take even numbers such as 2, 4, 6 and 8, we will get this result. Let me dwell more on this for now. Now, what is 2 pi by 2? It's pi. What is pi? 180 degrees. 4 pi by 2 is 2 pi, which is 360 degrees. Yes, 3 pi, 6 pi by 2. And what is 6 pi by 2? 3 pi. It is, yeah, 3 times 180, which is 540. If you observe, all these are horizontal lines. Yes, this is 180, this is 360, this is 540, and precisely this is 720. So, sine is negative here. For 2, it will come here. For 4, it will come somewhere here. In this quadrant, we know that sine value is negative. So for 2, we get negative, right? For 4, it is in this where everything is positive. So we get positive. Again, for 6 pi, we get it as negative, positive. So you can see that there is a cyclic arrangement where negative, positive, negative, positive. That is why we have plus or minus sine theta here. A quick example, what is sine 12 pi by 2 plus theta? So where were we? 8 is positive. Similarly, 10 is negative. 12 is positive. Yes, so we have positive value. So the answer is plus sine theta. What about odd? Similar concept, but it changes to cos theta. Now, what are the values of n we can take here? Only the odd numbers such as 1, 3, 5 and 7. Now, what is 1 pi by 2? 90. 3 pi by 2? 270. 5 pi by 2? 450. So you can see, instead of the horizontal line which we took in the previous case, we are taking the vertical line. So, position of cos here is negative and here it is, yes, cos is positive in the fourth quadrant. ASTC, all students take coffee. Yeah, that is the significance of writing this ASTC rule. So, if we go in a cyclic order, n pi by 2 it is negative, for 3 pi by 2 it is positive, for 5 pi by 2 it is again negative. So you can see a similar cyclic arrangement or the alternating arrangement that we saw in the case of a odd number. Yes, so therefore we have plus and minus, but we have cos theta here because of this particular thing, right? We know that sine 90 plus theta is cos theta because of complementary angles. That is the reason we got cos here. So let's take a small example. What is sine 11 pi by 2 plus theta? Now for 7 we got positive here, right? For 9 it will be negative. For 11 again it will be positive. Cyclic, right? So this will be equal to plus cos theta. There are some more standard derivatives. So we will be seeing these examples in our next lecture. Thank you for watching this video. Please make sure to like this video and subscribe. Also, leave in the comment section for any suggestions, feedback, and any shortcomings. Stay safe, stay home. Bye.